This is the second video in the atomic theory lecture, and this video is going to focus on Thomson. So where we left off was talking about Dalton, who had a 4-part atomic theory, and we talked about if we had to draw Dalton's model, it would just pretty much be a sphere, and that we know something is coming because we know that the atom contains the proton, electron, and neutron, and where we left off with Dalton, he did not know that. So the next theorist we meet is J.J. Thomson, and the year is 1897, and he is an English physicist. So he actually studied physics and not chemistry. And he is credited with the discovery of the electron using something called a cathode ray tube. Okay. So I'm going to draw you a picture, and then we will discuss it kind of in bullet point form, I guess, on what exactly happened. So let's see. So we had this voltage supply, like a battery, and then some wiring, and then a glass tube. Okay, and in that glass tube were the cathode and the anode. So just like you know that batteries have a positive and a negative side, and you have to put them in your TV remote the correct way, this idea of the cathode and the anode had a positive and a negative side. Okay, so what Thomson did, and when we are in person, we will watch a video on this, and it will help to explain this. He used an experiment that involved passing electric current through a gas. Okay, that was in this glass tube. So what happened is, I believe he used hydrogen first, and he filled this glass tube with hydrogen, okay, and then turned the battery supply on. So then there's electric current running through here. And when he turned the battery supply on, he saw kind of a beam of light. Okay, and it ran from the cathode to the anode. So it was running this direction. And then he took a magnet. This is going to be hard for me to show you on here. He took a magnet to that beam, and he attempted to attract it or deflect it. So when he put the magnet one direction up to that beam of light, it attracted. Okay, and he was actually able to bend the beam of light. And then when he flipped the magnet around, right, we know that magnets have two, oh goodness gracious, have two sides. So when he flipped the magnet around the other way to that beam of light, the beam deflected and went away from the magnet. Okay, so after he turned the current on, he saw a glowing beam light. He used a magnet to attract and deflect the beam. Okay, and that's what happened, which meant that the beam contained charged particles. And he was able to determine that the beam was attracted to the positive end of the magnet. Okay, which meant, if we know our rules, opposites attract. So thus, he was able to conclude that this beam contained negatively charged particles, which he calls electrons. Okay? So, now, he thought it could be a fluke, and so, as any good scientist would do, he came back up to the experiment. He filled that glass tube with numerous different gases, and each time he got the same result, that the beam was deflected by the negative end of a magnet and attracted by the positive end of the magnet. And so he was able to conclude that all these gases contained negatively charged particles, and he calls them electrons. So that is why Thomson is credited with the discovery of the electron. But there's kind of a but coming. And it's that Thomson knew something. Thomson knew that all atoms are neutral. Okay? Meaning they are overall neither positive or negative. So Thomson thought, how can this be? If I know there are negative electrons, there have to be positive something to balance out those negatives. Okay, so he kind of made that statement. He stated that those positive particles existed, but he couldn't prove it. But he made sure to say that they were there. So, last thing for this video on Thomson is what Thomson's model would look like. So Thomson knew the atom existed. He also knew that the negative electrons floated around in here somewhere. I'm just drawing minuses for negatives. Okay. But then Thomson knew something else. And what Thomson knew was that there were positive particles. He just didn't know where they were. So he kind of scribbled in his model and said all this space is just an area of positive charge. Okay, because he didn't really know. So he said, that looks bad. He said the green there was this positively charged area. And of course, the black were the electrons that are negative. Okay, Thomson's model quickly gained the nickname the plum pudding model. That's because in England, where he was from, they eat plum pudding, and this reminded people of plum pudding with the negative electrons being like the chunks of plum. So kind of silly. If you've ever heard of plum pudding or the plum pudding model, it was Thomson's model of the atom. Okay, so that's where we leave off with Thomson. He discovers the electron. He's pretty sure there are positive